All right, this video is about the last unit, the last topic in Unit 1. So this is talking about advantages from trade. So far we talked about production possibilities curve. And all of our production possibilities curve so far, for example, when we did the jumping jacks and the math facts in class, it was bowed out. Because remember, we talked about the fact that everybody doesn't have the same skill set, and so we have to give up, for example, increasing amounts of jumping jacks to get more math facts, or vice versa. But let's assume, let's make it nice and simple. What if we're talking about we have two people, okay, or even two countries, and we want to specialize. So specialization is going to be where we have everybody getting more of what they want. So basically what we're going to do is that in the case of the jumping jacks and the math facts, I randomly just asked, for volunteers. And I just said, okay, the first time we did this, we did as many jumping jacks as you could in 1 minute. And then the second time you did as many jumping jacks as you could, or math facts as you could in 1 minute. And then the third time, what we did was that I just asked for volunteers who wants to do jumping jacks, who wants to do math facts, which was fine, right? It wasn't exactly precise, but what if we actually wanted to look at who should do jumping jacks and who should do math facts? Well, let's assume we're just going to look at two people, just to make it nice and simple and easy. So let's say that we have person one over here that can either do 20 math facts in 1 minute, or they can do 80 jumping jacks in 1 minute. And then we have a second person over here who can do 12 math facts in a minute, or they can do 60 jumping jacks in a minute. So what do you notice, obviously? Hopefully you notice that person one is actually better at doing math facts and jumping jacks because they are producing more of both of them. Okay, this is what we call absolute advantage, when there is more production with the same amount of or fewer resources. So in this case, who has an absolute advantage? So in math facts, who has an absolute advantage? Who can produce more math facts? Person one, right? Who can produce more jumping jacks? Person one, right? What if I went and made it so that, let's say that this person didn't make 20 math facts, let's say they only produced 10. In this case, okay, now who has an absolute advantage in math facts? Person two, okay, because person two is making more math facts than person one. All right, now, does this mean, let's assume that we're going back to the original, what I originally have here. Does this mean that we should not specialize? Hopefully you said no, right? Because if you think about it, person one is better at doing both things, but can they do both things? Imagine this weird scenario where they're trying to do jumping jacks and math facts at the same time. Look kind of strange. So what we are going to do instead is that we have to determine who should do what, okay? So in other words, what we have to determine is, okay, what does person two suck less at, basically, okay? And in order to do that, we are going to look at something called comparative advantage. So comparative advantage is the ability to produce something at a lower opportunity cost than anybody else. So now you're looking at what the opportunity cost is of producing one more jumping jack or one more math fact. And again, it depends upon the person. So let's go back to the same chart that I had on the last slide. So it's the same chart, but now what we're doing is that I'm adding a little space in here to do a little bit of computation. Okay, so if we are talking about person one, we're talking about person one, we are trying to figure out how many jumping jacks does person one have to get up for every one math fact. So if they have one math fact, they're getting one math fact, how many jumping jacks are they going to give up? Well, in order to do this, a big rule to determine is to determine opportunity cost, you've got to remember other goes over. So what that means is that we are putting 80, because that's the other item, the jumping jacks, okay, over however many math facts. So to determine how many math facts, so for every one math fact, to determine how many jumping jacks I give up, I have to do 80 over 20. So every one math fact I do, this person one does, they are giving up the opportunity to do 4 jumping jacks. Okay? Now, for the jumping jack side of things, okay, for every one jumping jack that person 1 does, how many math facts are they going to give up? Remember, other goes over. So in this case, it's going to be 20 over 80, which is 1/4. Yes, you will notice that this is the reciprocal. Okay, so once you figure out one, you just have to flip it for the other one. Okay, so for every one jumping jack, you are giving up 1/4 of a math fact. All right, so then for person 2, okay, for person 2, you are now going and you are, for one math fact, okay, you are giving up how many jumping jacks? You're going to go 60, which is the other item, jumping jacks, over 12. 60 over 12 will give you 5. So for every one math fact, this person is giving up 5 jumping jacks. And for jumping jacks, okay, for one jumping jack, they are going to give up 12 over 60. So 12 over 60 reduces down to 1/5. Okay, now why is this important? Well, comparative advantage determines specialization. So whoever has the lower comparative advantage determines who should actually produce that product and who should specialize in that product. So if you look at this, okay, who should be, I'll make this blue, who should be making math facts? Well, look at your opportunity cost. Opportunity cost for person 1 here was 4. Opportunity cost for person 2 was 5. Okay, so who has a lower opportunity cost? Person 1. So person 1 should do the math facts. So over here, it should make sense, it should work out then that person 2 should be doing jumping jacks. And it does, because look, 1/5 is smaller than 1/4. So person 2 should be doing the jumping jacks. Okay, so whoever has a lower comparative advantage, that's determining the specialization. Okay. Now, the other part we can also determine is who the terms of trade. So, now that we know, okay, person 1 is doing math facts and person 2 is doing jumping jacks, I know this sounds weird, but what if they wanted to trade? How much should they trade for? Well, if you think about it, okay, they're only going to trade, okay, for however many that they could produce on their own. What I mean by that is, for example, with, let's say, person 1, we know that they're making math facts, okay? So they need to trade math facts for jumping jacks, okay? So for every one math fact that they are trading, because they're making math facts, they want to trade for how many jumping jacks? Let's say that they're going to do 1 for 1. If they do 1 for 1, one math fact for one jumping jack, why does that not work? Well, if you think about it, look at this. They could go, and for every one math fact, they could go, and they're giving up 4 jumping jacks. So they could go and conceivably go and make this on their own. Right? And that doesn't make any sense. They say, no, that's not worth it, right? So in order for it to be beneficial for person 1, they have to at least get whatever their opportunity cost is for their math facts. So they have to at least get 4 jumping jacks in order for it to be worth it for them. Okay? On the flip side, for person 2, they're going to be looking for every one jumping jack, they want to at least get 1/5 of a math fact, because that's what they can make on their own, right? So one jumping jack equals 1/5 of a math fact. Now, oftentimes you will see that there is some sort of discrepancy between this, because, for example, okay, one math fact for 4 jumping jacks, does person 2 like that? Yes, they do. Okay, because they have an opportunity cost of 5 jumping jacks. So they want to be anywhere between 4 and 5 jumping jacks. So actually you could do anything between 4 and 5 would be acceptable. So if you want to say even 4.5, that would be acceptable. Okay. So in order to determine terms of trade, you have to look at whatever the opportunity cost is. So something between the opportunity cost between these two countries, that's what they would agree on. But you have to look at it from both sides because on a multiple choice question, you would find that there is going to be options that could include either way. Okay, so you got to make sure that you can do that. I will tell you that there is practice on comparative and absolute advantage on Canvas. So I'll show you that in a minute. All right, so last slide that I wanted to show you and talk about is the type of problem determines how to find opportunity costs. So far what I've been talking about is jumping jacks and math facts, which is actually what we call an output problem. An output problem is basically look at whatever it is produced. So the other goes over method that I was just showing you, it determines opportunity costs, it determines who should specialize, and it determines terms of trade. So that whole jumping jacks and math facts thing, that's an output problem. Okay, so that's pretty much what we've been already doing. However, there is another type of problem that you could possibly see, and this is what we call an input problem. An input problem looks at the resources used to produce a product. So in other words, you have to go first, convert it to an output, and then you use other goes over. I need to like put some punctuation in my weird point there. So an output problem would look at all the resources, so the land, the labor, the capital, the entrepreneurship that goes into making an item. And so oftentimes they would say, for example, either on the example it would say, you know, it takes this many hours to produce a ton of you know, oats, or this many hours to produce a bushel of corn, right? Or this many hours to produce this many cars, okay? But it could also be looked at, for example, I've also seen acreage examples where they say it takes this many acres to produce wheat, this many acres to produce corn, okay? So what you have to do is you have to figure out, first of all, what the output would be. Okay, so I'll give you an example. So if I'm converting, and bear with me here, if I'm converting my jumping jacks math facts thing into an input problem, okay, what I could say is that the time it takes to produce 10 math facts or 10 jumping jacks, okay, so notice this is a time issue. So this is telling you it's an output problem. So anytime you see in the little boxes here that it has time in there, it's an input problem. So person 1, it takes them 20 seconds to produce 10 math facts, or they can use 5 seconds to produce 10 jumping jacks. Person 2, it'll take them 60 seconds to produce 10 math facts, or 10 seconds to produce 10 jumping jacks. So the first thing that you have to do is you have to figure out what the output is. So in other words, how many math facts or jumping jacks can they produce in 1 second? Okay, so for example, for person 1, 10 math facts in 20 seconds means how many math facts can they produce in 1 second? So you're doing 10 divided by 20 to get half a math fact. You know, it's weird. Okay, so person 2, on the other hand, okay, can produce 10 math facts in 60 seconds. So 10 divided by 60 will tell you that they can produce 1/6 of a math fact in 1 second. Okay, going over to jumping jacks, person 1 can produce 10 jumping jacks in 5 seconds. So in 1 second, they can produce 2 jumping jacks. So 10 divided by 5. For person 2, they can produce 10 jumping jacks in 10 seconds, so 10 divided by 10 will tell you that they can do 1 jumping jack per second. Okay, now that we actually have our output, now we actually have it down to math facts and jumping jacks, now what I want you to do is pause the video and I want you to figure out what the opportunity cost is and who should produce what. Okay, hopefully you took some time to be able to figure out the opportunity cost. So let's start with person 1. Person 1 for math facts, other goes over, so their other item is 2, so 2 divided by 1/2. So 2 divided by 1/2 is 4, right? For person 2, where the other goes over, so 1 over 1/6 will give you 6. For person 1 in jumping jacks, other goes over, so 1/2 divided by 2 will give you 1/4. And person 2, other goes over, 1/6 divided by 1, which will give you 1/6. Okay, so now who should do what? Here comes our here comes our comparative advantage. So who should do what for math facts? Still person 1. Who should do what for jumping jacks? Still person 2. All right. Terms of trade, what would they be acceptable for trade? Anything between 4 and 6 for one math fact for jumping jacks, between 4 and 6. So they would probably agree on, because they would argue and fight over this, so they would probably agree on one math fact for 5 jumping jacks, because it's nice and easy and in the middle. That would be the terms of trade. Okay, hopefully that all made sense. Now, if you need extra practice, there is a practice worksheet on Canvas that we did in class. And so everybody worked on it in class, so that way I could help, as well as your group can help you. We will go through the answers in class. Let me know if you have any questions. Thanks.